Good morning, Miss Carly.
Good morning.
Um, Nobody else has jumped in the conference yet, but let me tell you that Quest um, extended the deadline for your recommendation. So I'm keeping an eye on it. I'm not going to let that deadline sneak by me, but they gave me a little bit of extra time to get all this other stuff going first.
Yes. Yeah, take your time. Thank you so much.
All right, I won't miss the deadline. I just might use it right up until the deadline, depending on how other things are going.
Oh, yeah, that's fine.
Good morning, Miss Kelsey.
Good morning.
Good morning, Miss Summer. I'm glad your internet's working today.
Yeah, we'll see if it continues to work the full time.
If not, I'll have it taped for you.
Thank you.
You're welcome. What y'all think about verifying trigonometric identities? Did you start to feel like you had the hang of it just a little bit?
I did just a little bit, but I do have a few questions.
Okay, that's certainly fair because I can't think of any other time in your mathematical life so far that you just had to write down a problem and stare at it with no guidance as to what to try. You know, there's no steps to apply here. Now, I say with no guidance as to what to apply, but I did give you a toolbox. So if you write down a problem and don't know what else to do, look in your toolbox and just go, which one of these tools even makes sense on this problem? And you really have to get comfortable at trying something, not knowing whether or not it's going to work. And if it doesn't work, just mark it out and try something else. Tell me one of the problems you're talking about. What can I do for you?
Okay, this is just a question.
Okay.
On like problem 87.
87, yes.
The cosine. Is it how to figure that out? Is it x over radius and radius always positive?
Yes, exactly. So the sign of cosine isn't going to depend on the sign of the radius because the radius is going to be positive regardless, but the cosine is going to be positive wherever x is positive. And sine is going to be positive wherever y is positive. And, tell me for 10,000 bonus points, in what two quadrants is tangent positive?
Quadrant 1, 3?
Yes, and not because you have to memorize that, but because you say in quadrant 1, you'd have a positive divided by a positive, and in quadrant 3, you'd have a negative divided by a negative. All right, what else? You said a few questions, so what else can I do for you?
89.
89. This is interesting. It's not the ones I thought you were going to ask me about, but maybe we'll do a few proofs in a moment. All right. Who asked me this one? Who was that?
Kelsey.
Kelsey. Did you look at number 90 and try to do it similar to that one?
Yes.
Somebody needs to mute their microphone. We're getting breakfast sounds and all kind of stuff. You said yes, Miss Kelsey, you did? Look at number 90?
Yeah.
Okay. On number 90, the fact that cosine was negative told us x had to be negative, and then you told me in what two quadrants cotangent is positive, so we were able to figure out what quadrant theta had to be in based on these two things. And on number 89, in what two quadrants would sine be positive? Sine is which coordinate?
1 and 2.
Yes, because sine is y over r, and y is positive in quadrants 1 and 2. And in what two quadrants is tangent negative? Where the x divided by the y would give you a negative answer.
Is it 2 and 4?
Yes. If you need a quick something, you don't have to get extra wrinkles on your forehead. You just want to make yourself a quick note. You could write this down. In the first quadrant, both quadrants or coordinates are positive. In the second quadrant, x is negative, y is positive. In the third quadrant, they're both negative. And in the fourth quadrant, x is positive, y is negative. And then when you're asking yourself, where is tangent negative, you have a diagram to look at and say, where, if I divided that y by the x, would I get a negative? A positive divided by a negative gives me a negative, and a negative divided by a positive gives me a negative. So that would be quadrant 2 and quadrant 4. So if both of these things have to be true, if tangent has to be negative and sine has to be positive, in what one quadrant, in what one quadrant would both of those things be true?
2.
Yeah, in quadrant 2, your sine is positive, but your tangent would be negative. That tells me that theta, here's a new symbol for you, theta is in the second quadrant. Now on number 87 and 88, that's all I had to do, find what quadrant theta lies in. But 89, not only did it say find what quadrant theta lies in, but also find the other trigonometric values of theta. Well, the easy one would be if tangent is negative 3/4, then what does cotangent have to be? If tangent's negative 3/4, what's cotangent?
Negative 4 over 3.
Right. So that one we can tell just by looking at what we're given. But to find sine and cosine, I think we're going to have to draw the triangle. Draw a second quadrant angle. That angle's always with respect to the x-axis. So I'm going to drop a vertical line down to the x-axis and say, there's my second quadrant angle where theta, I'm sorry, somebody's making noise behind me. Second quadrant angle, period. I don't know what I was about to say. Now we need to label that triangle in such a way that the tangent of theta is negative 3/4. Which two sides of a triangle does tangent give me? Using the words opposite, adjacent, hypotenuse.
Opposite and adjacent?
Yeah, tangent's your opposite over your adjacent. Another way to think of it is it's your y over your x. That means y is 3, or actually negative 3, and x is 4, which by the Pythagorean theorem means that the hypotenuse has to be 5. So first you figure out in what quadrant theta lies, and then you draw a picture of theta in that quadrant and label the sides according to what you're given. Then you can extract from that triangle all the rest of the trigonometric functions. You can say sine of theta would have to be opposite over hypotenuse. And cosine of theta would have to be adjacent over hypotenuse.
So, Miss Miles?
Yes, ma'am.
With the y being, how is that negative 3 if the y's are positive?
Oh, wait, did I do something stupid? Yes, I absolutely did something stupid. I'm glad you caught me at it. the whole point of determining in what quadrant theta lay, trying to think of correct grammar there. The whole point of determining that is to see whether that negative went with the 3 or the 4, and I didn't pay attention to that. If the angle theta is in the second quadrant, it's your x that's negative, not your y. So you were absolutely right. That's why I had to figure out it's in the second quadrant to know that that negative went with my x, not my y. So that is not correct. And that was not correct. Thank you so much. Miss Kelsey, was that you that asked about 89?
Yes. And I know what I did wrong. So
Okay.
yes.
Did it happen to be the same thing I did wrong?
No, with the tangent, I had x over y instead of y over x with the.
Oh, that's cotangent.
Mm-hmm.
All right. Somebody have another one. What about, I can't believe no one's asked me about one of the identities yet. So let me double check, because I never know if everybody's saying I don't have a question or if everybody's on mute. Is there anyone that has a question about any of the identities 51 through 74? Well, I think that's pretty darn cool. That may be the only time that nobody's had any questions over the identities, but if you figured them out, that's fantastic. Let me see, officially then, we are through with what we're supposed to do because y'all haven't covered you haven't watched the 5.3 video. Let me just show you something from it.
And Miss Miles,
Yes.
I see that I had another question whenever
Okay.
after this.
No, go ahead, before this.
Okay. On 85 D, where
Yes.
it says 3 pi, how would we do that on the unit circle?
I'm glad you asked. Because I was actually fixing to pull out my unit circle and say, up until this point, we've been talking about a circle of any radius, and we just called it R. We said sine of theta is y over r, cosine of theta is x over r, and tangent theta is y over x, but r can be anything. R is going to depend on what x and y are. We have a formula for finding r, the Pythagorean theorem, square root of x squared plus y squared. All right, so we've been talking about a circle of any radius. What we're about to do in 5.3 is to go from a circle with any radius to a circle of radius 1. And even though I've been using the word unit circle or the phrase unit circle prematurely, I should have been saying a circle of any radius. Hold on, something just popped up on my computer. I should have been saying a circle of any radius, and I want to make sure that you understand why we can just say, well, let's only talk about circles of radius 1. I mentioned when we were talking about the, and I am eventually getting to your question, I promise, but I mentioned when we were talking about trigonometric functions of right triangles, if we had a 3, 4, 5 triangle with that being theta, or we had a 6, 8, 10 triangle with this being theta. There's the same proportion. These are called similar triangles. They have the same ratios, even though this side is twice, or this side is twice as long as that one. this one is twice as long as that one, and this one is twice as long as that one. So they're similar triangles. The sine of theta in this one would be 4/5. The sine of theta in this one is 8/10, but 8/10 reduces to 4/5. So it doesn't matter when we put that on the unit circle. It wouldn't matter if we had a circle with a radius of 5 or a circle of radius 10. The trigonometric functions of theta would be the same. It was supposed to be an r, not another 10. So in 5.3, we're about to say, just to make life easier, let's stop talking about a circle of radius r and move everything to a circle of radius 1. And then we'll get the definitions instead of, and this is the 5.3 notes, instead of saying sine is y/r, if you're on the unit circle where r is 1, we're just going to say sine is the y, and cosine is the x, and tangent's the y/x. But the only reason that we can disregard the r is because we would actually be forming similar triangles, and the trigonometric functions of similar triangles would be the same regardless of the length of the hypotenuse. So going back to your question, if this is a circle with radius 1, then we've had practice labeling the unit circle, and this blank template is in your 5.3 notes. You can print off as many of them as you want to, but you should be able to click around that circle by counting by multiples of 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. And you should be able to click around that circle counting by the multiples of 45, 45, 90, 135, 180, 225, 270, 315, 360. So you should be, in degrees, you should be able to count by multiples of 30 and multiples of 45. In radians, what did we say the radian measure of this 30-degree angle is? What were we counting by in radians? If you have to figure it out, think 360 degrees is how many radians in a whole unit circle?
2 pi.
2 pi. And so 180 degrees is how many pi?
1.
1 pi. And so 90 degrees is what fraction of pi? If this is
1/2 pi.
If this is 1 pi, then that's a 1/2 pi. And when we wanted the radian measure for 45 degrees, we said that's halfway to 90 degrees. What's halfway to pi over 2?
1/4.
Pi over 4. When we wanted 30 degrees, we said that's 1/3 of the way to pi over 6. What's 1/3 of the way? Oop, I said the answer. Sorry. I meant to say 1/3 of the way to pi over 2. What's 1/3 of the way to pi over 2? A third times pi over 2.
Pi over 6.
Thank you. Pi over 6. So we're going to get good at counting by pi over 4s and pi over 6s, just like we're good at counting at multiples of 30 degrees and multiple of 45 degrees. Now I'm finally ready for your question. I needed to get, I'm going to say 60 degrees. This is 1/6, that's 2/6, better known as 1/3 pi. But what you were supposed to do on number 85 in the homework is count by multiples of whatever you needed to until you got to, in the C part, 7/2 pi, and in the D part, 3 pi. So in the C part, I can count by half pies until I get to 7. I can say 1/2, 2/2, 3/2, 4/2, 5/2, 6/2, 7/2. So 7/2 pi would be on the negative x-axis, where counting in degrees, I would say that's 270 degrees. Counting by radians, I normally call it 3/2 pi, but 7/2 pi is coterminal. Oh, you can't see that. 7/2 pi is coterminal with 3/2 pi. It's just around the circle one whole time and another 3/2 pi. So what was it we were supposed to do in the C part? Give all 6 trigonometric functions of 3/2 pi. If that's the ordered pair 0, -1, then I could get sine and I could get cosine. And what could you tell me about tangent of 7/2 pi?
It's undefined.
It's undefined because it would be -1/0. So that's how you do the C part. Just count by half pies till you get to 7/2 pies. Now the D part said find the trigonometric functions of 3 pi. So I don't have to, I can skip the half pies. I can count by whole pies. I'm going to say 0 pi, 1 pi, 2 pi, 3 pi. 3 pi is coterminal with pi. And the ordered pair right here is -1, 0. So the trigonometric functions of 3 pi would be the same as the trigonometric functions of 1 pi. Now that's the longest explanation to a single question I've ever given, but I also covered what I was about to say in 5.3. We're no longer talking about a circle of any radius. Let's just make it simple and talk about a circle with radius 1. Miss Kelsey, was it you that asked me the D part? Or yeah, the D part 3 pi?
Yes.
Does that make sense now?
Yes, it does.
Okay, so if I said find the trigonometric functions at maybe 13/6. If I said find the trigonometric functions at 13/6 pi, my first thought was, well, all the multiples of pi over 6, one of the ordered pairs or one of the coordinates is 1/2 and the other is square root of 3 over 2. So I just need to find which is x and which is y. If I'm trying to get to 13/6, is that what I said? I don't know what I said, but let's say I want to find the trigonometric functions of 13/6 pi. I just have to find out where 13/6 pi is. And so I'm going to count by 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 9, 6, 10, 6, 11, 6, 12, 6. And when I say 12/6, I better be landing on 2 pi because that's what 12/6 is. And then one more would give me 13/6. So I could say 13/6 is coterminal with pi over 6. Whatever the trigonometric functions of pi over 6 are, the trigonometric functions of 13/6 pi would be the same thing. So all I need to know is the ordered pair right here. And again, at all the pi over 6's, one of the coordinates is 1/2, one of the coordinates is square root of 3 over 2. And to figure out which is which, I just want to think right here, the ordered pair was 1, 0. Right here, is it my x or my y that's close to 1?
X.
Yeah, I just left where X is 1. I'm not yet to where Y is 1. I'm closer to where X is 1. So X is square root of 3 over 2, and Y is a half. And now I can tell you the sine of 30 degrees, the cosine of 30 degrees, the tangent of pi over 6. And I don't have to have my unit circle all filled out to figure that out. Let me give y'all one. And right now you may want the whole unit circle in front of you, but our goal is to not have to have the whole unit circle in front of you. It's for you to have this tattooed on your eyelid, the inside of your eyelid, and be able to click off by multiples of pi over 6 or multiples of pi over 4 until you get to the terminal side of whatever angle you're given, and just label the ordered pair on the unit circle on that terminal side. So if I said find the trigonometric functions of, let me think for a second, what do I want to do? Find the trigonometric functions of 10/3 pi. Is 10/3 a multiple of pi over 6 or a multiple of pi over 4? Anybody? Is
Pi over
10/3?
6.
Yeah, it's not a multiple of 4, it's a multiple of 3. So it's counting by pi over 6s. So here's what I'm thinking, and the only way I can show you what I'm thinking is to write it down. I'm thinking 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, sorry, 10/6, 11/6, 12/6. What is 12/6 pi reduced to? What's 12/6? Yeah, that's 2 pi. So I'm just checking to make sure I'm on track when I get to 12/6. You know, there's one other thing I could have said here that might have been helpful to you. How many sixths is 10/3? Ten-thirds is how many sixths?
Is it 20?
Yeah. So I just go around this circle counting by sixth until I get to 20. I was right here, I was at 12/6. This is 13/6, 14/6, 15/6, 17, 18, 19, 26. 26 is right there. And I'm going to double check that. 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11, 6, 12, 13, 14, 15, 16, 17, 18, 19. Ah, I thought I missed it. I left out something. I don't know what I skipped before, but it's supposed to be this one. I'm going to double check it, or I guess triple check it now. I know that this is 12/6, so I'm just going to count 13, 14, 15, 16, 17, 18, 19, 26 is 10/3 pi. Now, since it's a multiple of sixth, I know that one of the coordinates is a half, and one of the square coordinates is square root of 3 over 2 with appropriate signs affixed. I know since I'm in the third quadrant, the x and the y are both going to be negative. Which one's going to be closer to -1, the x or the y right here? Tell me what this point on the y-axis is. If this is a unit circle, this radius is 1. What's that point on the y-axis?
Is that the negative square root of 3 over 2?
No, I'm talking about, I'm not talking about this point. I'm talking about the point on the y-axis.
Just be 1.
Yeah, y'all are making me just a little bit nervous. I'm wondering if you're not quite visualizing what you need to be visualizing yet. Let me back up. I'll come back to this, but all I'm saying is if my tick marks are counting by ones, then what's that point? If my tick marks are counting by ones, then that's the point 0, -1.
I thought you were talking about that line under or above
Yeah.
10/3 pi.
Yeah, I gotcha. But before I can figure out these coordinates, I need to figure out that coordinate.
Yeah.
And that coordinate is 0, -1. Now, everybody that was so silent when I kept saying, what is this ordered pair? Do you understand now that this is what I'm talking about? The radius is 1, so that's the ordered pair 0, -1.
Yes.
Okay, I'm going to be satisfied with one yes. Now that I have that point labeled, I can say, is it the x or the y at 10/3 pi that's closer to -1?
It'll be y.
Yeah, the y is almost -1. It's negative square root of 3 over 2. And the x is -1/2. And again, if my tick marks are counting by ones, which they are on the unit circle, sure enough, that would be about halfway to -1. My x is about -1/2. My y is almost -1. Y'all will get better and better at clicking around the unit circle and identifying the ordered pair and then being able to give all the trigonometric functions. What may seem kind of overwhelming, and I can't believe I'll ever have that in my head, I can promise you if you practice, you will. And it's very important that in calculus, it doesn't take you all day to figure out what the sine of 10/3 pi is. You might need to squint to figure out it's in the third quadrant close to the y-axis, but once you say it's in the third quadrant close to the y-axis, you should know y is negative square root of 3 over 2. So sine of 10/3 pi is negative square root of 3 over 2. Now, I'm going to punch on my calculator, see what square root of 3 over 2 is as a decimal. It's about 0.866. So I'm saying this is approximately 0.866. If I only wanted a decimal approximation, if I didn't care about the exact answer, I only wanted a decimal approximation of this on my calculator, should my calculator be in degree mode or radian mode?
Is it radian?
Unless you see a degree symbol, it's radian mode. So I'm going to put my calculator in radian mode by pressing the, on my calculator, it's the degree button. It's in radian mode. I'm going to enter the 10/3 pi, because I have the fabulous backwards calculator. I have to enter the 10/3 pi and then hit sign. So 10/3 pi is just, I hardly ever use my fraction button. I just enter fractions as division. 10 divided by 3 times pi. And then I want to hit equals to make the calculator do that multiplication. That's what 10/3 pi is equivalent to. Something about that bothers me. 10/3 is a little over 3. Yeah, 3 pi would be 9 something, so this is 10 something. Now if I take the sine of 10/3 pi in radian mode, I get the same, I forgot to write down my negative here, but I get the same decimal approximation that I did when I punched negative square root of 3 over 2 on the calculator. Any questions? Did any of you go to the website that I gave you in Momentum that you practice clicking around the unit circle and just giving trigonometric functions at 30 and 45 degree angles? Anybody try that out? You should. It's good. I'd go to Momentum and just play with that instead of playing, if I say Dungeons and Dragons, how old school is that? Is anybody still playing that?
Yeah.
Yeah. Okay. My
I feel
daughter-
weird, but yeah.
My 28-year-old daughter still has Dungeons and Dragons Party. That was the only game I could think of. Yeah, maybe you could skip D&D one night and play trigonometric functions of units of angles on the unit circle. That sounds way more fun to me.
Yeah, it sounds like an improvement, you know?
All right. I don't have anything else unless somebody else has a question for me. Going once. Going twice. I can't believe y'all didn't ask me any of the identities. All right. Let me say just one other thing then about tonight's homework. Since what you're supposed to have in my math lab is identities, and I don't know how I can find an identity that's just not duh when you put it in on the computer. What I may do tonight is give you 3 problems that I want you to send me the picture of your identity. I may do that. I will send you a remind after I look in my math lab and see if there's anything that I want to assign on there. I'll send you a remind, and the remind will either say, hey, I did find 6 problems to put in my math lab, or it may say, I only found 3 problems to put in my math lab. Do these other 3 and send me a picture of them. So I don't know exactly what you'll do for your homework grade tonight, but I will send you clear instructions either in remind or email. And if I send it in email, I'll send you a remind that says, check your email. Okie doke?
And that's for day 2 of 5.2, correct?
Correct. Day 2, 5.2 would include trigonometric identities, and then the kind of problems we were doing somewhere else. But yes, I'll let you know for sure what I want you to do for your homework grade tonight. Okie doke?
Alright.
All right, y'all have a great day. It's going to be a
Thank you.
beautiful day. Go play outside.
Wish we could.
You can go play outside in your yard. You just can't go to the park.
Yeah.
All right, see ya.
Bye.
Bye.